Yeah, so we're here with question 5, and it's basically 1 plus t e to the power of xt dx by dt um, plus x e to the power of xt is equal to 0. Now, before you go ahead, it's obviously for me, the best method is to see if you can put it in either one of these forms to make it really easy for you to solve. And for this particular equation, it's much easier to actually put it in this form. So by just multiplying both sides of the equation by dt, you get a simple equation as 1 plus t e to the power of xt all multiplied by dx plus x e to the power of xt multiplied by dt is equal to 0. Now, if you notice, it's exactly in this form. Now, so we can go ahead with the steps that are involved in solving an equation like this. So the first step is actually the test of exactness, which is checking if the partial derivative of q with respect to x is equal to the partial derivative of p with respect to t. So I should define p and t. This is my p of xt, and this is my q of xt. So if we go ahead and test that, our partial derivative of q of x is equal to e to the power of xt plus xt e to the power of xt, and our partial derivative of p with respect to t is equal to 0 plus e to the power of xt plus xt e to the power of xt, which, as you can see, they're equal. So you can actually continue with this equation. By finding out that they're equal, you can make the safe assumption that f of xy does exist. Now, the next step involves properties that have been defined before. So you know these are given properties. The partial derivative of of f with respect to dx is equal to p of xt, and the partial derivative of f with respect to q is equal to not q, it's early in the morning, with respect to t is equal to q of xt. So we're going to actually start off by integrating one of these equations so we can get a partial equation for f. I would suggest going with this equation, mainly because this is much easier to integrate than this because it has the 1. But again, it's completely your choice. You don't have to do what I'm saying. You can go ahead and do this. I'm going to start with this. So your your integral of your derivative of f with respect to t is equal to x e to xt. So now all you actually have to do is get your dt to the other side. So you get a df is equal to x e to the power of xt dt. All you have to do now is integrate both sides, and you get f of xt is equal to, since you're integrating for t, you actually don't have to worry about x. You can take x out of the integration, and you're left with xt dt. Now, like always, you'd have to use substitution, so it'd be the assumption of u is equal to xt, so your du by dt is equal to x, so your du over x is equal to dt. Oh, yeah. So then all you have to actually do is sub this in here, so you get an x is equal to x multiplied by the integration of e to the u by du over x. You can take this x out and it will actually cancel with this x, so you're just left with the integration of eu du, which is equal to eu plus I'm just going to go directly. So eu, so use xt, plus an equation that's g of x. Now, generally you'd put a constant like plus c, but because this is only a partial derivative, there's actually a second equation with respect to x, since we've only derived with respect to t, that exists. So right now, this is only a partial equation. So I'm going to write that out again over here. This is for you. So f is equal to e to the power of xt plus g of x. Just get all this out of the way. Now that we've used actually one equation, we can now go ahead and use the other one. So all we actually have to do is derive this. Well, we've used this one, so now we have to use this one. And if you notice, if we derive this equation with respect to x, we can actually solve for gx, since we know that this equation is equal to this. So if we derive this with respect to f, you will actually get t e to the power of xt plus g prime of x, which basically means this is equal to 1 plus t e to the xt. And if you notice, you have two t e to the xt's, so you can just cancel them out, and you're left with a g prime of x is equal to 1, which means your g of x is equal to x plus c. So now you can go ahead and substitute this into this equation. So you get f is equal to e to the xt plus x plus c. Now you're not done yet. You actually have to, you can simplify this more in the sense that you're supposed to actually solve for this general equation. And according to this general equation, if you notice, since the derivative of f is equal to 0, then f is going to be a constant k. So let me just write that down again. Derivative of x is equal to 0, so your f is equal to k. And you can easily substitute that in over here actually, so you have k is equal to e to xt plus x plus c. Now the thing is, your c can just get absorbed by the k since they both are constants, so it's no reason to write both of them twice. So this is actually your final answer. And it's important to not forget this. This is only applicable when you're actually given a 0 here. So you can make this assumption that since the derivative of f is equal to 0, f is going to be a constant. And then actually sub it into this equation. And then since you have two constants, they can just become into 1 and get absorbed. So that's your final answer for question 5 of assignment 1.